Hello everybody, this is Darryl at hudsonscustommachining.com. What we have here today is a collar for a Hunter ceiling fan. This is the Hunter Tuerk. I believe it's the Model B. But this is the collar that mounts underneath the beehive part of the motor that spins around. And this is where the blade irons fit onto here. And then of course your paddle blades fit on here. And we've got a fairly unusual part here in that when this part was casted at the factory back around 1900, whenever these fans were made, they call this the 1886 model, I believe. But they were made on through the early 1900s. And this is one-piece cast. This is all a one-piece casting. When it left the foundry all in one piece, this was machined out to be a smooth surface. And then these stubs here were machined out so that these blade irons could fit onto there and be tightened with a set screw. What we have is one that left the factory unfinished. If you'll notice, these stubs are turned, I think they're just under a ½ inch, like 0.499, 0.498 I think. And you'll notice that they center drilled on the face of each of these stubs here when they machined this down to this diameter. And that was done because this was done in a fixture. And what happened is they did 3 of these stubs, and then there was one that was left, it didn't get done. It got turned to the right diameter, but it didn't get drilled, the center drill in the face there like the rest of these have. And I think what happened is it was probably on a Friday afternoon. But this didn't get finished, and it got put in the box with the complete ones. So it got out and it got put on a fan and it got put into service. If you'll notice, on each of these stubs, don't look at this, on each of these stubs there's a drilled hole for the set screw. And if you'll notice, each one of these holes is off 12.5 degrees. It's not straight up. If this is level here, this is off 12.5 degrees that way. This one is off 12.5 degrees this way. And that's the way they're supposed to be, to have the proper pitch to the paddle so that it'll push the air in the direction that it's supposed to go. And the same deal here. This one is off 12.5 degrees this way, but now this is the one that didn't get finished. It didn't get finished on the end, and I think what happened is somebody drilled this by hand after the fact, after it left the factory or after it got assembled. Somebody realized, hey, they didn't drill the hole in here, which is offset 12.5 degrees, so they did it by hand. And what they did, they just drilled, instead of a detent that looks like this, I'll try to turn it so you can see, instead of a detent that looks like that for this set screw to go down into to set the pitch of the blade, they drilled it with apparently a hand drill, and they got it off. They didn't get it 12.5 degrees like it was supposed to be. It was more like 24 or 25 degrees. So my friend John Andrews down at Texas Ceiling Fans, who is doing some repairs to this fan to get it back complete again, sent it to me because this hole was off over here on this side. So the only reasonable fix for this was for me to set this up on the milling machine and find my 0 and then rotate this around 12.5 degrees for this stub here. And what I did, I milled down through the hole that somebody drilled, and I milled down far enough that I've got a little flat there. I've got a little flat down in here. Let's turn it this way so you can see. All right. See, I had to go down deep enough to get through that hole so that set screw, when it comes down on here, it wouldn't be persuaded to go to the wrong angle like it was before when they drilled it by hand. So what I've done here, now the set screw would probably go on down on this fine because the set screw is bigger in diameter than the hole there. But I made this little piece of shim here because, see, we also get into a balancing problem. I can't mill this all the way down to the bottom of that hole because we'll take off too much material here and we'll weaken this stub too much, and we'll also get into a balancing problem here. See, we've got to consider balance. All of these blade irons are balanced, and if you'll notice, this is how many grams this blade iron weighs. So we match these blade irons up so everything's balanced on here so that it'll rotate smoothly. So what I did is I made this little piece of stainless steel shim here, and I beveled it so that we can put it here, and it's flush. It's flush here, and of course this is on a radius here. So we had to bevel this in, and it needs to be a little bit narrower than this so that the blade hub will go on there. Okay, so that's what that's going to look like. And then when we put the blade iron on, let's see if I can push this on up here. I'm trying to do this with one hand. Okay, now we've got the blade iron on, and I don't know if you can see down in the hole, but there's the shim down in the hole there. Maybe you can see the outline of the circle. There it is right there. You can see that shim down in there. Now, so when we put the set screw in there, the set screw is pushing down on that shim, so the shim corrects our balancing potential balancing problem by putting a little bit of metal back in there, and it also gives the face of this set screw a place to seat down on a good flat surface without any persuasion from that little small hole underneath, trying to make this set screw go one way or the other. And then we can tighten this on down, and this thing's ready to go back into service again. So I want to thank John Andrews for trusting in me to take care of this problem for him. John is in Austin, Texas at Texas Ceiling Fans. I'm located here in Aiken, South Carolina. Hudson'sCustomMachining.com. All right, that's all for now. Y'all take care.